Okay, we're going to start the next talk now. Amazon OpsWorks, some guys from DNA, and Chris Barclay from Amazon.
Yep. Is mic on? Okay. It's here. Thank you for having us. I'm Yuichi. My full name is Yuichiro Mori. I'm from DNA. And can you introduce yourself? Yep.
Hi, I'm Garrett. I'm also from DNA.
Yep. And we also have Chris from Amazon, and he's going to talk after us. And yep. And we are DNA, we are server engineer from DNA, and let us introduce what we're doing simply, briefly. So we are providing game platforms for mobile games, for iOS and Android. Well, and we also include the feature phone in Japan, actually, but we are focusing on Android and iOS on West Market. And we are also, at the same time, we are also game developers. And these are some major games that we worked on. And some of them are built in Vancouver studio, and some of them are built in US studios, and some of them are provided by Japanese studios. And well, today's talk is about OpsWorks, and OpsWorks is actually used in the NFL matchups, the one at the top. And most of the games that we have, well, actually all of the games that we have is the mobile platform game with social abilities, and it's usually thin client or a little bit more client and the web server. And this is how our structures look like. So it looks like ordinary web infrastructure with the EOBs as the load balancer and some web nodes. And we have data stores, Memcache, Redis, and MySQL. And we're also using the SQS for the messaging. And we're using the SQS for the consumer, with the consumer subscriber consumer model. And we're using that for the push notifications and other offline asynchronous tasks. And our gaming client is the usually thin client with the web view inside. So all the game feature is provided by server side. So all the players will connect to our web service for internet.
Sure. So how do we get all of our stack set up? Well, we're using OpsWorks. If anyone has used it before, this is what the interface looks like. You'll find it through Amazon's web service. Nice little beta version of it right now. If you click on the drop-down on Amazon to see all of the available services, it's there. You guys should check it out even if you're not going to use it, because it has a lot of features you might find very useful. So for example, we have stack, layers, and instances. Those are the main components of your typical infrastructure. The stack is the top level. It indicates with configuration what you're wanting to set up, and anything that Chef might require for configuration for running its recipes and things like that, to apply them to your instances. The layers allow you to add more granularity to the stack. So for example, we can have web nodes or MySQL or Memcache, and we can separate them so we can indicate per layer what we want to apply to them from the configuration we've set up in the stack. Lastly, we have the instances, which can be permanent, always running, or time or load based. With the always running instances, we can do things like set the host name, and then we can also set up the configuration that and pick the layer that we want to apply it to. So if we have a stack that's for our NFL game, and we have a layer that's specifically for the web node, we can say, okay, create an instance in the web node, call it machine 1, and set up the configuration to say, I want to apply Java for the JVM on there and that kind of thing. I also wanted to mention that OpsWorks allows you to set up permissions, your IAM permissions. So if you want certain developers or ops people to have access to things, you don't have to go through the Amazon IAM. You can actually apply your configuration here to those instances or to those stacks, which just makes it a little bit easier because I find the interface is easier to navigate than with the AWS native interface. I mentioned Chef, and I'd like to say it's magnificent. It's pretty good. The type of Chef that's being used in OpsWorks is very similar to Chef Solo, if anyone's used it, where all of the recipes are required to be on that instance and available. It's not set up like the typical Chef server setup. So if you go to Chef and you read up on it, ops code says, you got your server and you've got your clients. And all of the configuration resides on your server. And then your clients ask your server, I need to run something for my environment. What's the configuration for that? And what recipes do I run? So the difference here with OpsWorks is the recipes have to reside on the machine or in S3 so that it can talk to it locally and then run them locally. So it's, what's the word there? It's more decentralized. So if we're taking a look here, a typical Chef setup in OpsWorks, you'll see these defaults. It has different life event cycles. So when a server starts up, it's going to do its setup phase. It'll then do its configuration phase. And if you have something you're deploying, which is the whole purpose of having the instance in the first place, you have this generic deploy. What you can do, though, is you can add to these. So if you're creating your own Chef recipes, you would go into the configuration, add some of these plays or recipes and have them applied when this machine boots up. So if you're doing one machine in a layer, you can have it applied to that one. But if you're adding 10 or 20 or 30, this gets applied to each of them as they start up. So you don't have to worry about going in after the fact and targeting all of them individually or in a batch and saying apply them. It just automatically gets handled for you. And you've also got the undeploy or shutdown, which does any cleanup if you wanted to do that. Did I miss anything? I think I'm good. So you're up.
Okay, then let me explain how we integrate our workflow with it. So for initial setup with Stack, OpsWorks Chef takes care of everything. So when you need an additional stack or when you need additional server in the layer, you just have to go through your web interface and add another server. Well, you still have to select which type of instance you want, but you just have to click through web interface and apply whatever change you want. And once you boot up, Chef takes care of everything. Chef applies the setup recipe and the deployment recipe, and it's put into online mode and does everything. So when we need additional server, when we find out there's not enough server on the web path, or when you find there's not enough server on the data store, you just have to go to web interface and add another server there. And once you boot up, all the recipes that you need will be applied automatically. So there's nothing manual. You still have to manually put the server on, but that's the only thing you have to do. So that's how we do use the OpsWorks Chef for this initial setup. And for the deployment, we integrate through Jenkins mainly. So we use GitHub Enterprise, and all the commits goes into GitHub Enterprise, and Jenkins detects it. And because we're using Java, Jenkins compiles everything and they put into S3. So all the commits, Jenkins detects all the commits that's put into GitHub Enterprise, and Jenkins will package them into artifact and push them into S3 so that all the recipe can refer to that artifact. And how we deploy that is it is also triggered by Jenkins. So we load some scripts to orchestrate all the recipes because at this moment, OpsWorks doesn't support you to do the blue-green deployment, which is like keeping online and keeping old version as online and building new servers and swap them without downtime. So it was not supported, so we load some script to do that. So that's what Jenkins runs. And so how Jenkins works is the Jenkins updates the OpsWorks stack config, which keeps what version needs to be updated. Well, what version has to be pulled from S3, and then it kicks the recipe on OpsWorks chef. And OpsWorks chef runs the recipe that's specified into the stack. And inside the recipe, it refers to the artifact on the S3. So it pulls down the artifact that has been pre-built before and put them into a stack and puts up new instances. And once the new instances are up and ready, Jenkins detects it and puts the new instances into the ELB automatically. And at the same time, it pulls out all the instances out. That's how we do the blue-green deployment. And there were some challenges that we faced with, not because of the OpsWorks, but because of our game structure. Because our game is event-based, we have like weekly events and weekly deploys, and all the players are already expecting when changes happen. I mean, all the players already know when the changes happen and then when the change is coming. So once we deploy the new changes, there's going to be drastic change in the traffic volume. So this is how the traffic volume look like. The one square with the red line is how the traffic spike changes, or traffic spikes. Number of requests triples,
quadruples, yeah.
In 20 minutes. So this is obviously some challenge that we faced. I mean, previously we dealt with this with overcapacity. I mean, having overcapacity on web nodes, and which is not great. And the solution that we have with the OpsWorks chef is using the time-based instance. So with this time-based instances, you can schedule when you need the additional instances. In this case, it's only 2 instances are scheduled to be up. But you can schedule them to be up at a specific time on a specific day. So if you're expecting a huge traffic spike on like today and 5 o'clock, you just have to click 5 o'clock square. Well,
we also clicked 4 o'clock.
Yeah. Yep. The problem that we had it takes a little bit of time to be. It takes a little bit of time for instances to be completely hot and up. So we also select 4 o'clock square to make the 5 o'clock spike, to avoid the 5 o'clock spike to be down.
Sure. You do the pros cons.
Okay.
Yeah.
Okay. So here's the pros and cons that we find with OpsWorks Chef. Good thing about OpsWorks Chef, Amazon OpsWorks is it's a chef that we know, and it's quite simplified, and it has a little bit of extended feature as well, which is the live events that we talked about. Like all the instances goes to all the live events. When the instance boots up, it automatically applies setup recipe, and then it applies the deployment recipe, and then it applies the configure recipe into all of the instances that's on the stack. And so that was quite simple enough, and at the same time, it's extended enough. And the good thing about Chef is the infrastructure as a code. So everything that you have to mention, everything that you have to document is already in the code with enough description. So you don't really have to make the documents. and it's already reproducible with the recipes. So that was really great for us. And it has the basic metrics built already, which let you know what's happening. Well, we actually integrate the new lyric as well, so we also use the new lyric as a basic metrics, but it supplements this new lyric at all. And it lets you see each instances, how each instances are working. And this has provided us peace in my mind, a piece of mind.
It's made your mind more peaceful.
Yeah.
This guy's worked a lot of hours on this project.
Yeah, well, previously, actually, we were managing all the instances manually, so it has made us a lot easier. But there is cons as well. Obviously, it is tied into service, and if the Amazon stops to provide it, we still have chef recipes, but it's not going to be automatic anymore. And it's still new services. We find sometimes with behavior, like you cannot delete the instances that you want. But it's that actually never affected in the service time. Like it never made us down. But there are some like maturity issues.
We've had time-based instances not turn on when we expected them, so then we had to add some manual ones as well. Regarding the comment here about metrics, so this is like CPU usage, memory, and hard drive capacity. And this metric here is actually from New Relic, so we're able to track requests and throughput and see what's going on. And that integrated fairly well with the application that was already built. It's a Java application running in Play and using a lot of Java and almost no Play. It's pretty much. Okay, so we're going to finish off before giving it over to Chris with our wish list. We mentioned blue-green deploy a couple times, which is the ability to swap between what's currently running with our new deploy and gracefully pull out what's currently running so that we don't hard drop connections and let those processes finish, just to give our users a better experience because we want them there and playing and giving us money. Next up, we have more time granularity. So you saw we were able to select by the hour, but we really only need by 10 minutes or by the minute. Something where we can say 10 minutes before 5 o'clock, spin up, get hot, and then handle the load for a half hour because that's all we really need. We don't need 2 hours, we need 35 minutes. Then we've also got here elastic IPs. So we've had to do some workarounds because we didn't have the ability for OpsWorks to set up the elastic IPs. So for example, our firewall configuration is applied after the server is already running using Chef because we can't set it up before in the original configuration before it starts because we don't know what the IP is going to be. So that's been some of our issues. And I don't know, up until now, it's been mostly good stuff. So Chris, why don't you tell us a little bit about how you guys are using it and how other people are using it.
Sure. So thank you to the DNA folks for inviting me. So I just wanted to talk a little bit about some of the use cases that we see in customers and started off with just kind of one of the things that I guess everyone here probably experiences, which is that we have to assume that things are going to break, right? So one of the principles of the model that we're all looking at is assume failure and let's go ahead and try to architect for that assumption. So, if we're going to embrace and plan for failure, what does that mean? It probably means that we start treating every piece of our infrastructure as code. And I think that's one of the neat things about the both public and private cloud models that we're seeing is that you can treat your infrastructure as code, so your instances, your network config, your storage config, and that can be version controlled in your repo in the same way as your actual code. And then, of course, you can use tools like Chef and Puppet and Ansible to treat the software that you're running on your servers as code as well. So what does that allow us to do? Well, we can now start rolling back and forward. So if we have problems, it's pretty easy for us to recover. And we can set up environments to test things a lot more easily than we perhaps could have previously. So it's pretty simple for me now to create a staging environment that looks exactly the same as my production environment, and I can roll code in there that I'm planning on putting out and test it with all my integration tests and maybe even some real-world tests, some load tests, and I can feel a lot more confident, kind of like our previous speaker on Test Kitchen said. I can have that confidence that things are going to work well. And I can also plan for failures. So one of the things that we do at Amazon, probably many of you do as well, is we call them game days, and we try to actually assault our applications in ways that they might be assaulted in production, and then have an operations team try to recover, and come up with operational playbooks to recover from failures and make sure that we're monitoring for those things. And the nice thing about coming up with these operational playbooks when you're not kind of live in production is that then when those failures happen, you kind of actually have a little